Ashley here from Smart Addition Academy. Today we are going to focus on Algebra 101. So we're going to talk about all of the topics that you need to know in the algebra realm of mathematics for your specific entrance exam. So I'm really excited to dive into this and talk about some of the topics that you will need to know. So some questions we're going to answer together today. What do I need to know about algebra? So we're going to talk about specific topics within algebra that you need to know to be successful on your entrance exam. So hopefully we'll clear up any issues you might have or any, questions or curiosities you have in that area. How do I solve algebraic equations? So this is a big part of your entrance exam, is being confident solving algebraic equations. Talk about tips and tricks for that and how to do that confidently and solve these questions accurately. We're going to talk about how to tackle word problems, because a big part of algebra is taking word problems and turning them into math. So we're going to talk about setting up equations, plugging in values, lots of different ways that we can tackle word problems that we will see on our exam. And then lastly, what will the problems look like? So we're going to do a bunch of practice problems together today. Okay, so let's jump into this today. What do I need to know about algebra for my exam? So here are the topics that we are going to talk about today. It's pretty much covers everything algebra-wise that you will need to know for your entrance exam. So algebraic equations, like I said in the beginning, very important. We are going to talk about how to solve simple and complex equations. So simple equations start with, 1-2 step equations we have to solve, and they get more and more complicated, where we may have parentheses we need to distribute to get rid of. We may have to combine like terms. We may have to move variables over from one side to the other. So we're going to talk about how to solve those equations. We're also going to talk about evaluating expressions. So plugging a value in for a variable to an expression to simplify and find the value of that expression. We are also going to talk about exponents. Okay, so we're going to evaluate exponents. Like, for example, 5 squared, how do I figure out what that is? And then also talk about exponent rules. So if you have exponents with the same base, then there's some cool special rules that we will talk about to get together today to simplify and solve some of those problems that you may see. Let's see. We're also going to talk about polynomials. So polynomials are essentially variables with an exponent. So like, for example, x squared, we see quadratics a lot. We're going to talk about polynomials. They get, more complicated. They could be really anything. But it's essentially just something with multiple terms here. We're going to talk about simplifying polynomials using addition, subtraction, multiplication. How are we going to simplify those polynomials? And then, of course, like I mentioned, we're going to talk a lot about word problems. Okay, so let's jump into it. We'll start with equations. So here are a few tips for tackling algebraic equations. So what I like to do is I like to think about solving equations like unwrapping a present. So whenever you have an equation that you're trying to solve, you essentially have a variable that's been wrapped up with different operations, okay? And your goal, the end goal, is always to get the variable by itself. So you have to unwrap, you have to undo those operations in order to get the variable by itself. So I like to just think about it as unwrapping a present. So we're going to use order of operations backwards to undo those operations. So when we have learned order of operations in the past, PEMDAS, this has taught us how to simplify and solve expressions. When we do it to solve an equation, we're essentially like doing it backwards. So if I had something like 3x plus 5 equals 3x plus 5, let's say 23, okay? I would want to work backwards, meaning I would take care of the addition and subtraction first, okay? So I would do minus 5 first in order to start to solve and simplify. So we're going to talk a lot more in depth about this, but that's what I mean by doing order of operations backwards. Okay, always important to keep the end goal in mind. Your end goal is to get the variable by itself. So everything that you do should be with that goal in mind. How can I get the variable by itself? And sometimes we take extra steps, and that's okay as long as we get to that end goal. But trying to keep that in mind can help us be a little bit more efficient. A couple more tips. You can plug the solution back in to check your answer. So once you find, okay, I think x is equal to 4, plug it back into your original equation, and then you should find whether that works or not. See if you get a true statement. We'll do a few of those as well. And then if you get stuck, if you get to an equation that you really just can't figure out how to solve, you have no idea how to get started, most of these will be multiple choice. So I'm going to show you how you can use the multiple choice answers to help you in those situations that you get stuck. Okay, so a couple things to look out for as we start to solve some more complex equations. We will probably deal with parentheses. So you're going to want to try to get rid of them by simplifying or distributing. Usually distribution is the way we're going to get rid of parentheses, meaning that if I have something like 3 times x plus 5, to get rid of those parentheses, I have to distribute this. I have to multiply out in order to drop those parentheses, okay? So likely will be something we will see in a bit. Then you will want to deal with like terms. So try to simplify your equations by combining like terms before you solve them. Okay, if you can simplify your equations before trying to solve and combine like terms, get like terms together, then it's going to just make it seem a little bit more manageable. When we are dealing with equations that have variables on both sides of the equation, we're going to practice moving one of the variables over to the other side by using inverse operations so that we don't have to deal with it on both sides. We want to get our variables together so then it's easier with, again, our end goal in mind to get to that variable by itself. And then just to reiterate this little pro tip, you can always check your answer by plugging your solution back into the original equation. So no matter how complex these are, we should be doing really well on these types of questions because we can always, always, always check our answer, okay? Even if it takes 30 seconds to a minute, it's likely worth it in order to get the answer correct, okay? So let's dive into some examples. Before we jump into our first practice question, let's talk TEAS test prep. To pass, you need to feel confident and good about how you prepared. Our online course and mobile app make test prep simple and easy. Get all of the information you need to pass your TEAS and get into your dream school with our online course available at smartadditionacademy.com. And we're going to start off simple, and then we'll look at some more complex examples as we go. So if you have a scrap piece of paper, I would definitely have that handy so you could be doing some of these with me. If you have a calculator, remember you can use a 4-function calculator on your exam. So have a calculator handy because that will also be helpful here. So 3x plus 5 equals 35. If I'm trying to solve this equation for x, my end goal is to get x by itself. I need to move over everything else that is attached to it. So order of operations backwards, right? I'm undoing what was done to it. Essentially what happened here is the variable was multiplied by 3. So 3 times your variable, and then they added 5, okay? Now, in order to undo it, I want to get rid of the 5 first. So I'm going to do the opposite of addition, which is subtraction. I'm going to subtract 5 from that side to get it to cancel out. Now, when we have an equation, you always do the same thing to both sides. So I'm just going to make sure that if I do it to one side, I do it to the other side. So I'm left with 3x equals 30. And then 3x means 3 times x. So I'm going to do the opposite, which is division. That will get it to cancel out. And if I do it on one side, I need to do it to the other side. So I end up getting x equals 30 divided by 3 is 10. Now, if I wanted to check my answer, I could just plug this back in for x. So is 3 times 10 plus 5 equal to 35? 30 plus 5 equals 35, and this is a true statement because 30 plus 5 is 35. So you end up with a true statement of 35 equals 35. Okay, let's try another one. W divided by 2 minus 8 equals 10. So order of operations telling me to do the subtraction, get rid of that subtraction. I need to do inverse operation of addition to get it to cancel out. And if I do it on one side, I need to do it on the other side. So I'm left with W divided by 2 equals 18. Okay, so if I have W divided by 2 to get rid of division, I use the inverse operation of multiplication. Okay, so 18 times 2 would give me 36. Okay, so can I check quickly and see if that works? Let's see, 36 divided by 2 minus 8 equals 10. 36 divided by 2 is 18. 18 minus 8 equals 10. That is true because 10 equals 10 is a true statement. So see how quickly it is to just plug it in and check your answer just to make sure you didn't make a silly mistake. Okay, now 4x minus 7 equals x plus 8. What we can do here is we can subtract the x from both sides first. So when we're dealing with something like this, an equation like this, variables on both sides of the equation, I want to get them on the same side so it's easier to get x by itself. So I'm just going to subtract x from both sides. So 4x minus x would leave me with 3x. 3x minus 7 equals 8. And now I have a pretty simple equation to solve. Just like we've been doing, we're going to get rid of the addition and subtraction first. So the inverse would tell me to add. 8 plus 7 is 15. So 3x equals 15. I'm going to do the opposite of multiplication, which is division, to get x equals 5. Okay, and now let's see. If I plug in 5 here, I get 4 times 5 minus 7 equals 5 plus 8. So 20 minus 7, 5 plus 8 is 13. 20 minus 7 is 13. So we know we got it right. We can be confident in our answer. Okay, so hope you guys are feeling pretty good after a few of those examples. We're going to dive into a few more complicated equations to solve. Okay, so buckle up. It's going to get more complicated, but we're going to take our time. We're going to go nice and slow, and we're going to go through the process. So solve this equation for the unknown. Okay, so take a moment, look at this equation, and think about what we could do to make it look a little bit simpler. I'm going to give you one more moment. All right, let's try to combine some like terms, okay? So I see lots going on the left side of the equation and on the right side of the equation. If I can combine like terms, I can make it seem a lot more simple. So I notice I have a 3x plus 2x on the left side. I have a minus 8 and a plus 5. So let's combine those terms. 3x plus 2x is 5x. Minus 8 plus 5 is minus 3, okay? Now, on the right side of the equation, what can I combine? Well, I have 4x minus x, which would be 3x. So 3x plus 6. Now I'm dealing with something very similar to what I had in the last example, where I just have variables on both sides of the equation. If I can deal with that, I can make it a lot simpler. So let's subtract 3x from both sides. I like to keep my x's on the left if I can, and also just keep positives when possible. So 5x minus 3x is 2x. 2x minus 3 equals 6. I'm going to add the 3 to both sides to get it to cancel out. And then my last step, just divide each side by 2, and I get x equals 9 over 2. So I'm noticing that in my answers, all my answer options were fractions, so it's fine to leave it as 9 over 2. If it had been decimals, you could just divide 9 divided by 2 to get your final answer. But because they left it as fractions, then we are okay. Cool. All right, let's try another one. Okay, so this is an example with parentheses. So to deal with these parentheses, we want to distribute. Okay, let's distribute and drop those parentheses. So 2 times 4x, that would be 8x plus 2 times 1 would be 2, minus 5, equals 3 minus, so we distribute the negative sign, negative 4x, and then we have minus a negative 3, which is really plus 3. So now that we've distributed, we've dropped those parentheses. Our next step is going to be, can I simplify by combining like terms? So on the left side, it looks like I can do plus 2 minus 5. On the right side, I have 3 plus 3. So notice how I'm keeping the sign that's in front. You want to be really aware of your signs when you're combining like terms so that you add them correctly. So plus 2 minus 5 would be minus 3. 3 plus 3 is 6, and then minus 4x. Okay, now we're dealing with variables on both sides of the equation. So I'm going to move my 4x over. It's minus 4x, so I have to add 4x to get it to cancel out. And if I do it on one side, I have to do it on the other. So I get 12x minus 3 equals 6. And now we just need to add 3. 12x equals 9. And then my last step here, 12 times x, so I'm going to do division. I would get x equals 9 over 12. So notice how that does not match up perfectly with any of my answers. Okay, it looks like I need to simplify 9 over 12. So this is just a nice reminder that the foundational skills that we have for math, like with fractions, with decimals, they are going to still be very important as we are solving equations, working with more complex topics in algebra. So in order to simplify this fraction, I'm looking for a common factor. I can divide each of these by 3, and it should simplify to 3/4. So let's see, 3/4. There it is. Okay. So just for time purposes, I'm not going back in and plugging in each one now here to show you. But again, you saw how it worked with those first few examples. You could totally be plugging these answers back in. With fractions, the more complex equations, it will take a little bit longer. But if you're not feeling super confident, it is really helpful, and I think it's really worth it. All right, so speaking of fractions, let's try this example. I actually have 2 ways I want to show you to do this. So let's do the first way, just exactly what we've been doing, and then I'll show you a little trick if you want to try something a little bit different, okay? So first way we do this is the exact same thing as what we've been doing, where we're trying to get rid of these parentheses, so we just distribute. 3/4 x plus 3/4 times 3 would just be 9/4 minus 2 equals 3 minus, so negative 2/3 times x would just be minus 2/3 x. Negative 2/3 times 1 would just be minus 2/3. So from here, next thing I want to do is just combine like terms. So I can combine plus 9/4 minus 2. So if I just think about this a little bit, 9/4 minus 2, 2 is the same thing as 8/4. So 9/4 minus 8/4, that would leave me a positive 1/4 equals, and then on the left side, I can combine 3 minus 2/3. So if I think about that, 3 minus 2/3, I need to rewrite the 3 as something over 3. So this would be the same thing as 9/3. So this would be 7/3 minus 2/3 x. Okay, so now I am wanting to move my x's to the same side. So let's add 2/3 x. So again, just trying to think off to the side. Well, 3/4 plus 2/3. I need a common denominator. So I really want to be comfortable with fractions here. Same thing as 9/12 plus 8/12, so 17/12 times x plus 1/4 equals 7/3. Okay, and then we will subtract 1/4 from both sides. Again, can I figure out 7/3 minus 1/4? Well, I need a common denominator. So that's really what's making this more complicated here, is just having to deal with these fractions. So 17/12 times x, and then this would be equals 25/12. Whew, okay, almost there. Now, how do I get rid of this 17/12? It's 17/12 times x, so we could divide, by 17/12. Okay, we could divide by 17/12, which is fine. You would just have to remember how to divide fractions. Or a little bit quicker of a way to do it is to just multiply by the reciprocal. So all that means is you flip the fraction. So multiply by the reciprocal, you flip it. So if I multiply by 12 over 17, I would get a final answer of just what would be left is 25 over 17. Whew, so that was a lot. What was the hardest part of that? Okay, it wasn't really solving the equation. It was the fractions. So let's talk about a way to deal with this example, okay, without dealing with the fractions. So I'm going to just go down here and I'm going to rewrite this, okay? And let's just see how we can deal with this. So we have 3/4 times x plus 3 minus 2 equals 3 minus 2/3 x plus 1. All right, I think I got that right. So if we want to deal with this equation without the fractions, okay, we can actually multiply the entire equation by some number that will allow me to drop the fractions completely. So the number that we need is basically the least common multiple between whatever the denominators are. So 4 and 3, their least common multiple would be 12. So I'm going to multiply everything by 12. So basically I'm just distributing 12. So distribute that here, 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 here. So the hardest part about this is remembering to distribute to all of your terms. So 12 times 3/4, that would give me 9. So 9 times x plus 3 would be your first term. This is all just one term. Now I'm going to do 12 times -2, 12 times 3, 12 times -2/3, should be 8, I believe. And that's times x plus 1 because this, again, is just one term. So from here, now I don't have to deal with the fractions and I can just practice solving. So we're going to distribute to get rid of these parentheses. 9x plus 27 minus 24 equals 36 minus 8x minus 8. And now we're just going to combine like terms, all right? So same process we've been doing. We can combine 36 minus 8. Okay, and then from here, my goal is to get the x's on the same side of the equation. So I'm going to get 17x plus 3 equals 28. Now let's see, we're going to subtract 3 from both sides. 17x equals 25. Divide by 17, and you will notice we get the same answer either way, 25 over 17. Okay, so tell me what you think. Which option did you like better? I personally really like the least common multiple strategy because I'm not dealing with the fractions. I just have to like take care of that first step and then I can solve equations. But you can choose whichever way you like as we continue to solve. All right, let's keep it moving. So we just did quite a few pretty complex equations here. I want to show you one other type of equation you may need to solve. So this says solve the equation for the unknown w. So essentially what we want to do is we want to try to get w by itself. Okay, so we're trying to get w by itself. We're dealing with all these other variables, but we're going to follow the same process and just keep the end goal in mind of getting w by itself. So the first thing that I want to do is get rid of this 2l. Okay, it's a positive 2l, so we have to subtract it. So p minus 2l equals 2w. Okay, so what we can do here is then just divide each side by 2. And we're left with w equals p minus 2l all over 2. So notice how the process is the same, but we just have to keep the other variables within it. So we're basically solving for w in terms of p and l because p and l are still in our answer. So let's find the one that matches. It looks like option number 2. Okay, so you may see some equations like this where you just have to follow the process, move things over to get the variable by itself, and just be careful you can only combine like terms. So there was nothing really that we can combine in this example. All right. Let's do some evaluating of expressions. So evaluating expressions basically just means that we are plugging in values to figure out what the expression is worth. So if this is saying if x is equal to 6 and y is equal to -2, we need to simplify or evaluate this expression. So 3, and then instead of x, we're going to put 6. Instead of y, we're going to put -2. Plus 2 times, instead of y, we're going to put -2. So everywhere I see a variable, I'm going to plug in the value that they tell me up here. Okay, and then we're just going to simplify. So think about order of operations when you do this. Okay, whenever we are dealing with algebra, we want to keep order of operations in the back of our mind. Okay, so it looks like you should do the multiplication first and then add them together. So the first thing we would do, again, is the multiplication. 3 times 6 times -2 would simplify to -36. Positive 2 times -2 is a -4. So we would get -40 as our final answer. If you drop that in the chat, awesome job. Okay, let's try another one of evaluating expressions. So you have n times m squared. So this is telling me m is equal to 5 and n is equal to -1. So let's plug in. N is -1, m is 5. Now, how do I simplify this expression? Well, I need to do my exponent first. So -1 times 5 squared is 25. And then when I multiply -1 times 25, I get -25. Okay, so we'll talk a little bit more about exponents coming up shortly, but that's essentially all we need to do to simplify. Okay, and here's one I'll let you try on your own. Go ahead and take a moment and evaluate this expression if m is equal to 5 and n is equal to -3. Okay, so we'd have -5 times 5 plus -3. Okay, so -m is -5, and then in parentheses, m is 5 plus n is -3. So just be careful with your signs for this one. We're going to simplify the parentheses first. 5 plus -3 would just be 2. So -5 times 2 leaves me with -10 as my solution. Okay, so evaluating expressions, pretty straightforward, but again, one of those foundational skills that we need still is using order of operations or PEMDAS in the correct way so that we can simplify these correctly. All right, let's talk about exponents. So exponents are always written in this form. You have some base raised to some power. Okay, so the base is the big number, and then the power, or the exponent, which I just labeled as n in this example, is the little superscript above. So what this means is that we take a number, so like, for example, 5 squared. 5 is the base, 2 is the exponent, okay? This tells me that I need to do 5 times 5. I need to do it twice. That's what the exponent tells me. So this is basically just 5 times 5. So even though on your 4-function calculator, you may not be able to plug in exponents, you can figure out their values by just multiplying the correct number of times. So 5 squared is just 5 times 5, which is 25. Okay? 2 to the third, okay? You got your base of 2, your exponent of 3, means 2 times 2 times 2. So just be careful. Make sure you're multiplying it the correct number of times. Now, what is 2 times 2 times 2? Okay, so 2 times 2 is 4. 4 times 2 is 8. So you want to be careful not to be confused with 2 times 3. This is 2 to the third power. 2 times 2 times 2 is different. So 2 times 2 is 4, times 2 more would give me 8. All right, and then again, just something to be aware of when we are dealing with negatives. Notice how this is within the parentheses. So -5 to the third power means -5 times -5 times -5. So -5 times itself 3 times because the exponent is 3. -5 times -5 would give me 25, times a -5 again would leave me with -125 as my solution. Okay, so you can use your calculator to help you with these exponents, but it's just important to know what they mean when you see them. Okay, so another way you're going to see exponents is in order of operations questions. So again, I'm just going to right PEMDAS over here, making sure that we're doing things in the correct order. Okay, and dealing with your exponents within this expression, we're just going to do it in the right order, and then we'll deal with the exponents as we go. So the first thing we need to do is parentheses. So I'm going to simplify this. Within those parentheses, I need to do the exponent first. 4 squared is 16. 4 times 4 is 16. Now I can simplify this. 16 minus 10 is 6. And then I can move on to my exponents. 3 squared is 9. Now dealing with my multiplication and division, looks like I just have to do 5 times 6, which is 30. And then addition and subtraction. So take care of that. Addition I see first, so that's the first one I'm going to do. 39 minus 8, and when I simplify that at the end, I will get 31. Okay, so exponents are important to be able to simplify, but then you also need to know how to use them within other topics such as order of operations. Okay, so let me give you an order of operations question to try. Okay, so take a moment, and if you feel confident, go ahead and try to solve this one on your own. If you're not totally sure, maybe just drop in the chat. What do you think is the first step? What would be the first thing we would want to do if we're trying to solve this order of operations question? Okay, so we have to do those parentheses first. Okay, so if you're getting started, keep working on it on your own. If you need a little help, look at the parentheses first and then deal with that exponent 2 squared to see what happens next. Okay, so I'm just going to start writing in a few of my steps while some of you are working, and if you're just following along with me, that's quite all right. So you want to simplify that parenthesis, or those parentheses, and then work towards the exponent. And we talked about 2 to the 3rd power before, but remember that means 2 times 2 times 2. So don't make a mistake and write 6. 2 times 2 times 2 is 8. Okay, and then we can deal with the multiplication. And then lastly, we have to deal with the addition and subtraction. So just be aware when we're doing order of operations, if we're dealing with addition and subtraction, and also when we deal with multiplication and division, when you get to that step, you're just working from left to right. So I would deal with multiplication or division in whatever order I see it. And since there's only multiplication, we didn't have to worry about it. With addition and subtraction, we're going to do the same thing. Notice how I come across the subtraction first, 3 minus 4. So I have to do that first. And then I can add 24 to it. So your final answer should be a positive 23. Cool. All right, so now we're going to talk about some exponent rules. We're going to definitely do a little bit more practice with exponents. And as we go through this, this might be a great slide for you to screenshot or take a photo of on your camera as we are completing it, just so you have this to refer to. We have a similar chart to this in our Smart Addition course, so you can always find it there. But this is just something that I kind of tried to put together in a concise way to give you an example of each of these different exponent rules that help us simplify exponents. So again, just as a quick reminder, when we have exponents, we always have the base, okay, and then it's raised to the exponent. Okay, so if we have certain things in line, if we have exponents with the same base, we have some cool things we can do. And then we also have a few other rules I want to mention. So power of 1 rule basically means any base, okay? Any number raised to the power of 1 is always the same number. So 8 to the 1st power would just be 8. Okay, it doesn't matter what your base is. Anything to the 1st power is just that same number. Okay, the power of 0 rule says anything to the 0 power is equal to 1. So any base, doesn't matter what it is, to the 0 power will always be 1. So 4 to the 0 is equal to 1. Okay, so those are a couple rules that you want to know, just so that when you see these questions come up, you feel like you can simplify pretty confidently. So now let's talk about some rules when we have exponents with the same base. So the product rule is when we are multiplying. So I have an exponent with the same base. Okay, so we have x to the a times x to the b. The rule is that we add those exponents. So I'm just going to add the exponents. So looking at an example, 5 to the third times 5 to the sixth. You would keep the base, and 3 plus 6 would become your new exponent, which would just simplify to 5 to the ninth. Okay, so product rule says if we're multiplying exponents with the same base, we just add those exponents. Similarly, the quotient rule, if we have exponents with the same base and we're dividing, this time we're just going to subtract. So 7 to the ninth over 7 to the fifth would be 7 to the 9 minus 5, which would simplify to 7 to the fourth power. Okay, so product rule and quotient rule will definitely come in handy. Okay, and then we also have the power to a power rule, which is basically just saying I could take an exponent with a variable or a base with some exponent, raise it to another power, raise it to another exponent, and what you do is you just multiply those exponents. So 2 to the third raised to the fifth. If you think about what that means, that really just means 2 to the third times itself 5 times. Okay, so essentially we're just adding 3 over and over and over again 5 times, but a quicker way to do that is just to do 2 to the 3 times 5, which is 2 to the 15th power. Okay. 2 more little rules here. Negative exponent. We in math typically do not like to have negative exponents. So what we want to do is we want to make the exponent positive. And the way that we do that is we push the exponent to the bottom. So x to the negative a is the same thing as 1 over x to the a. Okay, so 6 to the negative fourth is the same thing as 1 over 6 to the fourth. And you can do this as well if the exponent on the bottom is the one that's negative. So if I had, for example, 1 over 3 to the negative second, okay, I could simplify this to be just 3 to the positive second. I would actually push it to the top. So that's important to note. You'll definitely see that come up. All right, and then lastly, fractional exponents. If you have an exponent that is a fraction, it is the same thing as a radical. So x to the a over b would be equal to the b root. So whatever, it was kind of hard to write it in this software, but basically the b root means it could be squared to the third, to the fourth, like whatever that root is. And then underneath the radical, you have x to the a power. So what does that look like in an example? Well, 9 to the 2/3 is 9 squared, okay? But this is under the cube root, so the cube root of 9 squared. So whatever is on the bottom goes here. Whatever is on the top stays as your exponent. Okay, so the cube root of 9 squared. All right, so let's see how we can apply some of these rules. All right, these are some examples straight from our Smart Addition courses and practice tests. So let's simplify. 5 to the 6th times 5 to the negative third. Well, remember our rule for power to, our rule for products. 5 to the 6th times 5 to the negative third would be 5 to the 6 plus negative 3, which would simplify to 5 to the positive 3. Okay, so sometimes you'll be able to leave your answer as an exponent. And sometimes I want you to simplify and find the actual value. So 5 to the third, we could just do 5 times 5 times 5, and you would get 125. Okay, let's try the next one. 2x squared raised to the 4th power. So this is a power to a power rule. I need to basically make sure I raise everything to the 4th power. So this is the same thing as 2 to the 4th times x And then 2 times 4 would be my new exponent. So 2 to the 4th, 2 times 2 times 2 times 2 would be 16. And then x to the 2 times 4 would be the 8th. Okay, so 16x to the 8th. All right, so let's try another power rule here. X to the negative second over y squared raised to the third power. So when we are dealing with fractions within here, you just have to, again, make sure you distribute this power out here to all of these. In this case, we're doing it to the top and the bottom. So x to the negative 2 times 3. My rule is you multiply them over y to the 2 times 3. So this is really just x to the negative 6th over y to the 6th. Now remember, we really don't like negative exponents in math, so we want to push it to the bottom. So I would just have 1 over x to the 6th, y to the 6th as my final answer. Okay, let's try to simplify some stuff here. X squared, y to the negative second, over x to the negative third, y to the third. So if we think about what's happening here, we've got multiplication on the top and the bottom, but this fraction bar really means division. So we can only simplify exponents with the same base. So I'm just going to look at the division here and then see if I can simplify these at all. So x squared over x to the negative third would be x to the 2 minus negative 3. So remember, our quotient rule is to subtract. And then y to the negative 2 minus 3. So what happens when I simplify these? 2 minus negative 3 is a positive 5. Negative 2 minus 3 is negative 5. So I want to get rid of that negative exponent so the x to the 5th can stay. But the y to the negative 5th, I'm going to push it to the bottom to make it positive. All right, let's try another one here. Negative 5 squared times negative 5 to the negative second, all over negative 5 to the negative third. Okay, so all of these are the same base, which is nice, so I can use my exponent rules. I'm going to deal with the multiplication on top first. So negative 5 squared times negative 5 to the negative second. That is negative 5, and then that's to the 2 plus negative 2 power. Okay, and then I'm just going to leave what's on the bottom here. So how do I simplify that? 2 plus negative 2 is just 0. So this is really negative 5 to the 0 power. Do you remember what negative 5 to the 0 power would be? Or anything to the 0 power? Go ahead and drop it in the chat if you remember. What could I simplify this top part to? Negative 5 to the 0 power. Yeah, so if you remember, our 0 power rule is just that anything to the 0 power is 1. So this is just really 1. So I have 1 over negative 5 to the negative third. I want to get rid of that negative 3. So in this case, since it's already on the bottom, I get to push it to the top. So negative 5 to the positive third. And I would probably be asked to simplify this even further to get the actual value. Negative 5 times negative 5 times negative 5 would give me a negative 125 as my solution. Okay, so lots of different strategies here that we used, but the main thing that I want you to really be comfortable with is this slide. So I'm just going to bounce back to this here. And I'll give you a moment to screenshot each section of it. So power of 1 rule. And actually, maybe I can just zoom out a little bit so we can do this a little more efficiently. Okay, so exponent rules, power of 1, power of 0, product rule, and quotient rule. I'm going to take a picture or screenshot of that. And then lastly, we've got power to a power, negative exponent, and fractional exponent as well. All right, awesome. Let's keep it moving. Our time is flying by together today. I want to talk about some polynomial stuff. How do we simplify polynomials? So dealing with polynomials is essentially just combining like terms. So we talked about combining like terms when we were solving equations. So we're just going to do that with a little bit more to it because now we have variables with exponents. So combining like terms, in this case, I have to take this here plus what I see here in parentheses. So in this example, the parentheses actually don't make a difference. So we can just kind of drop them or ignore them. And then I'm just going to combine terms with the same variable. So I see a negative 3x squared. Do I see any other x squared? Well, I do. I see 5x squared. So I can combine those. Then I see minus 2xy. Do I see anything else that has an xy? I see a plus 3xy, so those can be combined. And then I see plus 4y squared. I'm looking for something that has a y squared, and that's what I see here. So I can only combine things that have the exact same set of variables to it. So negative 3x squared plus 5x squared would be 2x squared. Negative 2xy plus 3xy would be plus xy or plus 1xy. And then plus 4y squared minus 3y squared would just be a positive y squared. So I'm just practicing combining like terms. And now let's find the one that matches best. It looks like that would be option number 4. Okay. So we do have to be careful though when we are dealing with subtraction. If we need to simplify an expression like this is when the parentheses do matter. So notice how I'm taking this and subtracting this whole set of terms from it. So we're going to distribute this minus sign. So we have 8x squared minus 6x minus 3. Then minus 4x squared minus a negative is really plus 5x. And then minus 4. Okay, so now once I've got to this step, I can combine like terms. So I see 8x squared minus 4x squared. See minus 6x plus 5x minus 3 minus 4. So combining like terms, 8 minus 4 is 4x squared. Negative 6 plus 5 is negative x. Negative 3 minus 4 is negative 7. So 4x squared minus x minus 7. Okay, you guys think you want to try one on your own? Let's just distribute. I'll give you a moment to just distribute that negative sign, and then you can work towards combining like terms. Okay, so you want to just make sure you distribute that negative sign first, and then we can combine like terms. Okay, so I did minus 4x. Now I'm doing minus 2xy, and then minus negative 5 is really plus 5y. Okay, so just make sure that you're really careful when you distribute, and then go ahead and start combining like terms. And when you think you've got the answer, go ahead and type it in the chat. It looks like I am getting option number 3. So if you did 2, awesome job. And if not, just take a peek at my screen and see where maybe you made a little error. It's really easy to make mistakes with our signs in these types of questions. So no stress. I'd rather you make mistakes now than make them on your test. All right, so we talked about addition and subtraction with polynomials. Let's just do a couple examples with multiplication. We need to be confident multiplying binomials, okay, which is basically just double distribution. So I like to use the acronym FOIL, which stands for first, outer, inner, and last. So what does that look like? Well, I take the first term in each parentheses and multiply. So x times x is x squared. Outer, so the outside most terms, x times 6, that would be plus 6x. Inner, they're right next to each other here, plus 4x. And then last, 4 times 6 is 24. So once I've done that, now I can combine like terms in the middle. So x squared plus 10x plus 24 should be our final answer. So again, notice how all of the answer options look pretty similar. You just want to choose the one that matches up with what you have. In this case, they're all positive. Okay, So similarly to that, you may see some that have like a exponent attached to it. So x plus 8 squared really just means x plus 8 times x plus 8. I would absolutely recommend you always write it out like this so then we can follow that double distribution process. Okay, so x squared plus 8x plus 8x plus 64. Okay, so just following these little arrows that I set up for my distribution allows me to make sure I don't skip any terms. And when I combine my like terms in the middle, I get x squared plus 16x plus 64. Awesome. All right, so multiplying polynomials, essentially being able to do this double distribution is the most important thing that you will see. And as you're doing some more practice problems on your Smart Addition course, you will see can definitely get a little bit more complex, but this is the main concept, the main idea you need. Okay, so let's wrap it up with a couple word problems here before we run out of time. Okay, so just a few tips. I want you to practice your close reading skills. You'll notice I circle, underline, I rewrite information as we go. Want to draw pictures or diagrams. I especially find this helpful for geometry questions or like anything I can't quite get a hang of. I'll just try to draw so I can visualize it a little better. We're going to look for keywords like total means we're going to add things together. Maybe more than or less than will tell me should I add or subtract. Okay, writing out conversions or formulas that you might need so that you can just plug in can be really helpful. And then just a few things to ask yourself as you go. Can you estimate to find the answer? If it's a multiple choice question, if you can estimate, you could save yourself some trouble with some more complex math by just using more friendly numbers. And then if you get stuck, can you use multiple choice options to help you? Okay, so let's do a few examples before we run out of time. Celeste buys herself a fancy sports car. She put $3,200 towards it as a down payment and pays $712 a month for 5.5 years. How much does the sports car cost? So the total cost of this car is going to be her down payment, okay, plus her monthly payment over the whole course of, whatever her loan is. Okay, and our question is how much does it cost at the end? So we're going to take the down payment plus $712 a month for 5.5 years. Well, we need to make sure we multiply this by 12. This is how much she's paying per year. And then if we multiply that by 5.5, that will be how much she's paid over the life of the loan. Okay. So now we just have to simplify this. We're going to use our calculator to do the multiplication first. So 712 times 12 times 5.5, I'm getting, let's see, 46,992. And then I'm going to add after that. So making sure we're still doing order of operations correctly. Multiplication first, now we can add, and it looks like I should get $50,192 as the total cost of her car. Cell phone company charges $185 a minute for international phone calls. If a customer calls a foreign country and talks on the phone for 32 minutes, how much does the phone call cost? So we are charged $185 a minute and they talk on the phone for 32 minutes. How much does the phone call cost? Well, right here, this is telling me that I'm going to need to multiply $185 a minute times the 32 minutes. Should give me my total. So take a second, plug that in your calculator, and make sure you're able to get $59.20. Most likely it would give you 59.2, but you just have to know when we're talking about money, we want to go to 2 decimal places. So you just plop that 0 at the end. All right, let's try another one. If a taxi costs $8 plus $3.85 per mile and a customer needs to travel 14 miles, how much will their cab fare cost? So a taxi costs $8 basically just to get in, and then you have to pay $3.85 per mile. This customer is going to go 14 miles, and we want to know how much their cab fare is. So setting up like an expression for this to simplify is going to be really helpful. So we're going to take the $8 up front plus the 385 per mile times how many miles? Well, it told us 14 miles. Okay, so underlining just helps me pull out that important information. Now I can use my order of operations correctly. This would give me 53.9. So 8 plus 53.9 would give me 61.9. And because I'm talking about money, I'm just going to add that 0. So it gives me $61.90. All right, just got 2 more if you could bear with me here. Mike bought items that cost $478, $349, $679, $978, and $14.05. He had a coupon worth $5, and if he paid with a $50 bill, how much change did he receive? Well, the first thing we want to do here, it seems like, is figure out how much did he spend, or like how much did the items cost altogether. So I'm not going to write this out, but I'm just going to plug all these in my calculator. We're going to add all these together. So when we add all these together, 478 plus 349 plus 679 plus 978 plus 1405, I'm getting $38.89. So this is the cost of all those items. He had a coupon worth $5. So think about it. If you have a coupon, you're taking money off. So we get to subtract the $5. So he only owes $33.89. So he paid with a $50 bill. How much change does he receive? Well, 50 minus $33.89 would give me change of $16.11. Before we tackle this last practice question together, I want to make sure you're subscribed so you don't miss out on any new videos. Also, I want to remind you that if you're serious about your upcoming test and you really want to pass your test and get into your dream school, get the only online course that's guaranteed to help you pass. We offer videos, interactive lessons, a mobile app, practice tests, flashcards, and more. Get your course and start studying right away with instant access at www.smarteditionacademy.com. All right, so last one here. Notice how in the last example we had some decimals. We're going to have some fractions for this one to wrap it up. And again, as we're doing algebra, those foundational skills are still very important. So fruit salad is a mixture of 1 3/4 pounds of apple, 2 1/4 pounds of grapes, 1 1/4 pounds of banana. After the fruit is mixed, 1 1/2 are set aside. The rest is divided into 3 containers. And what is the weight of 1 container? So first thing I want to figure out is our total weight. So I'm going to add the apples, the grapes, and the bananas. So luckily for us, we've got common denominator here. So I'm just going to go through and add. So I have 1, 2 plus 1. So I have 4. And then 3/4 plus 1/4 plus 1/4 is 5/4. So normally we wouldn't leave it like this, but I still have other operations I have to do. So I'm just going to leave it for now. Because remember, now I have to set aside 1.5 pounds. So I'm going to subtract 1.5 pounds from my total to set aside. So now I need to get a common denominator. So good common denominator would just be 4. So I could just change this to 1 2/4. 4 minus 1 is 3. 5/4 minus 2/4 would be 3/4. Now my last step. It's divided into 3 containers and we need the weight of 1 container. So take your total and divide by 3. Okay, so typically when I'm dividing with fractions, I like to turn these into improper fractions. So 4 times 3 is 12, plus 3 would be 15. So 15/4 divided by 3 is the same thing as 15/4 times 1/3. And if you remember keep, change, flip, that is a great way to remember how to divide fractions. Then we can just multiply across the top and across the bottom, or we can cross cancel here and you get 5/4, which is the same thing as 1 1/4. So each container should weigh 1 1/4 pounds. Okay, so that word problem, the fractions made it a little more complicated, but it's also just kind of breaking down what is this problem asking me to do. Okay, so we covered a lot today. I hope you found this helpful. Please feel free to drop in the chat if you feel like we missed anything or any other videos you would love for us to make. Really enjoyed having you tonight, and I wish you the best of luck as you continue to study and on your exam.